The last operation on polynomials that we're working with today is division, and we are dividing by a single term. That's called a monomial. So 10x cubed minus 5x squared plus 20x is divided by 5x. What that really means is every term in the numerator is divided by 5x. So we call this the separate and simplify technique, because we're going to separate our terms in the numerator and divide them each by 5x. This allows us now to simplify. So 10 and 5 have a common factor of 5, so when we reduce, we'll be left with 2. Now look at this. X is in two locations at the same time. We know from our exponent rules that we're going to be shifting the base with the lower exponent. So when x to the positive 1 shifts, it becomes a negative 1. So we're left with 2x squared. In the middle, 5 reduces with 5. X to the 1 is the smaller. So x to the 1 has the smaller exponent, so it shifts and becomes a minus 1. So we are subtracting x in the middle. Last, let's find out what we'll be adding. 20 divided by 5 is exactly 4. And look at these bases of x. They are identical. That means they reduce to 1. So we will not have any x remaining in our last term. 2x squared minus x plus 4 is the final answer. In example 2, 3x to the 5th y squared minus 15x cubed y minus x squared y minus 6x is divided by a negative x squared y. What this means is every term in that numerator is divided by negative x squared. So we'll separate and then simplify. So we have 3x to the 5th y squared is divided by negative x squared y minus 15x cubed y divided by negative x squared y minus x squared y divided by negative x squared y minus 6x divided by negative x squared y. So we need to look for some reducing, and don't forget about the signs. We've got a positive divided by a negative. So we will have a negative fraction for the first piece of this answer. Looking at bases of x, 2 is smaller than 5. So x squared will be shifting into the numerator, and that exponent becomes a minus 2. So far we have 3x cubed. Base of y to the 1 compared with base of y squared. 1 is smaller, so this base shifts up, and we'll be subtracting that exponent of 1. So that leaves y. So we don't have a fraction remaining for that first piece. Next, notice that we have a subtraction sign and we have minus in our denominator, so that becomes plus. 15 is the only numerical coefficient. Bases of x, let's compare 3 with 2. So 2 is the smaller. That's going to be shifting up as a minus 2. Look at bases of y. They are identical. So the base of y reduces to 1. We have addition of 15 x to the 3 minus 2. That's just 1. Next, notice again we have subtraction and subtraction. So that changes to something being added. X squared, x squared. That's identical. That's reducing to 1. Y divided by y. Again, those are identical. That reduces to 1. So what you end up with is 1 multiplied by 1 divided by 1 multiplied by 1. Well, that's just 1. And finally, with the last term, we have subtraction and a negative, so that will be plus. We've got 6 in the numerator. That's the only numerical coefficient. We've got 2 bases of x, but this time x to the 1 is in the numerator, and that's lower than x squared, so it shifts down with -1. We only have 1 base of y, and it's already positive in the denominator, so this last term will actually be a fraction. 6 will remain in the numerator, but x, y are both collected in the denominator. So it might look a little bit odd, but this is the way it's written according to our exponent rules. So I hope you found this helpful.